In this video, we are going to focus on the mean, the median, and the mode. So when we talk about the mean, and this is the word that you usually think of when you hear the word average. Okay, so we can find the average by taking all the numbers, adding them up, and then dividing by how many that we have. So we're not going to use the word average because the word average could be mean, median, or mode. So we're going to be really specific when we talk about this. When we talk about the mean, we're taking the sum of all the values and we're going to divide by how many we have. So let's talk about our notation here. That funny looking E means sum of. So we're going to sum up all of the values. That's what the X means. Then we're going to divide by the total number of values. And that would give us the mean. Now, we could talk about the mean for a sample, or we could talk about the mean for a population, and there's notation associated with each one of those. If we see this X with a line over it, that's called X bar. And this is what we think of when we talk about the sample mean. And it's just sum of the X values divided by the total number in our sample. If we're talking about population mean, population parameters are going to use Greek letters. So we're going to see this Greek letter called mu to represent the population mean. And it's going to work the same way. Sum of all the X values divided by the total number we have. There's the notation difference here, though. When we're talking about a sample, we're going to use that lowercase n. And when we see a population, we're going to see that uppercase n. So let's just look at an easy example. Suppose that we're looking at the grades we have for tests in the class. Maybe we have a 93, a 72, an 81, and a 64. And we want to know our average test grade. So those are test grades. We're going to add them up. And we're going to divide by the total. And when we do this, we need to be careful. And I'm going to add this off screen using my calculator. So I've got 93 plus 72 plus 81 plus 64. So that's 310. So we're going to do that sum in the numerator first, and then we're going to divide that by 4. So the average in this case would be 77.5. And we would use that word average to talk about that mean. And I'm just going to assume that's a sample there. So when we talk about median, we're talking about the number that's in the center. What's nice about the median is that the median is not sensitive to outliers, and that's different from the median because, that's different from the mean because the mean is going to be sensitive to outliers. So why is the mean sensitive and the mean not? Well, when we talk about the mean, we're adding all of the numbers. So every single number gets used in this computation. Whereas the median, we're just going to take all the numbers, put them in order, and then find the one that's in the middle. So the stuff that's on the ends, which would be the outliers, really doesn't matter in this case. So let's go back to our example. We had the numbers 93, 72, 81, and 64. And let's say we want to find the median. Well, the first thing you have to do is put them in order first. So if I put them in order, it's going to look like that. Now notice in this case, we have an even number of numbers. So we actually have two numbers that's in the middle. The question is, what's the number that's in the middle of those? In this case, that would be the median. So we're just going to find the average of those two. So if I take 72 plus 81, I get 153. And if I divide that by 2, that's going to tell me the number that's in the middle. So we would say that's the median. And the notation for the median is going to be X with a little tilde over the top. And that means that we're looking at the median. Now, notation for the median, there's only one, and it's going to be this notation. We do not have a separate notation for a population like we do with the mean. So that's if we have an even number of values. What if we have an odd number of values? Let's say we've collected data like that. We have 5 values in this case. You still have to put them in order first. And I'm going to go from smallest to biggest. So they're going to go in order first. And then we're going to find what's in the middle. And the way I like to do that is I just mark them off on each end. And that works really well, especially with a really big data set. And that's going to tell us what's in the middle. In this case, what's in the middle is 73. So we would say our median, the x tilde, is going to be equal to 73. So slightly different for an even number of values versus an odd number of values. With an odd number of values, it will literally be whatever is that middle number. An even number of values, you're going to find 2 in the middle, and then you're going to average those. And now let's talk about mode. Mode is a number that occurs most often in a data set. Now, what's interesting about mode is that it can be used for categorical or discrete data. So we could do it for either one. Categorical or numerical data. Whereas the other two, we can only use numerical data to compute that. The data set could actually have no mode. So if we were to look at this last set, there was nothing that was repeated. So this would be a set with no mode. We could have a data set that has one mode, or we could have a data set that has more than one mode. Because we're just looking at most frequent here, it is not sensitive to outliers. So this data set would have no mode. Let's look at another data set. Suppose we have a data set that looks like that. If we were looking at the mode would be the number that happens most often, and that would be 9. And then we're going to see this other thing called mid-range. So the mid-range is really just the biggest value plus the smallest value divided by 2. So it's the average of the biggest and the smallest values. Because it's using the biggest and the smallest, it's very sensitive to outliers. So if we were to look at that last data set up here, and I wanted to find the mid-range, I would take the biggest plus the smallest and divide it by 2. So in this case, my biggest is 21, my smallest is 1, and I'm dividing by 2. I'm going to get 22 over 2, which is 11. Now, the mid-range is usually not very useful because it's using those extreme values. There is not a notation that goes with mid-range. There is not a notation that goes with mode. So we would just say mid-range equals. Mode, we would just say mode equals. Unlike median, we would say we could use the shorthand notation x tilde equals, or we could talk about mean, whether it's the sample or the population mean, and say that that equals something. No, just because we calculate something doesn't mean that it's going to make any kind of sense. So we really need to look at the context of the problem. So let's look at a few examples. Suppose we have zip codes of a few different places, and these are the zip codes of those places. And it's asking us to determine if the mean or the median is going to have any kind of meaning. Well, even though zip codes are numbers, zip codes are actually categorical data. So if I take these categories that are represented by numbers and I find the mean, or if I find the standard deviation, it's not going to have any kind of, or sorry, the mean or the median, it's not going to have any kind of meaning because it doesn't measure anything. Second one, let's look at ranks of selected medical schools such as Harvard, Johns Hopkins, New York University, Stanford, and Duke University. So I've got the ratings here. The question is, does this really mean anything if I find the mean or the median? And again, the answer is no. It's not going to mean anything. This is ordinal level of measurement. It was a way to rank them, but if I were to take all those rankings and I were to add them and divide by the number of rankings I have, it's just not going to, again, it's not going to mean anything. Why? Because we don't measure anything. Now, if we were to look at the cost of going to each of those medical schools, then we could find an average and we could find a median, and that would mean something because now we're measuring how much it costs to attend the school. But as far as rankings, it's not going to mean anything. Let's look at another one. Numbers on the jerseys of Super Bowl. Offensive. Again, it's not measuring anything, so this is not going to have any kind of meaning here. What about the top 5 annual compensation for chief executive officers? Is it going to mean anything? Well, we could take those salaries and we could find the average of the salaries, but is it going to mean anything in the context of CEOs in general? We're going to go no. Why would it not be? Well, we're only looking at the top 5, and this is not representative of the population. And then the last one, we have 50 mean ages computed from the means in each of the 50 states. Is this going to be meaningful? And I'm going to say no, it's not going to be meaningful. So there's several things that's going to make this not meaningful. The 50 mean ages computed from the means in each of the 50 states. Some states are more populated than others, right? So the population size of the 50 states really should be taken into account. So Texas probably has more people living in it than maybe Hawaii. And I'm just looking at the average. And I also remember averages suppress outliers. So I have 50 numbers, but the extremes are going to be suppressed because I'm taking all the numbers and I'm dividing by how many I have. I mean, means when I say averages here. So that's why this would not be meaningful because I'm suppressing outliers and I'm not taking into account the size of each of the states.